done, it ain't even fun no more. I'm jaded, man, it's just a game, I just played to play. I put my feet in the footprints left of me. Without saying the word, the ghetto's got a mental telepathy. Man, my brother hustles so naturally. Up next is me.
So, we're given the following problem. So we're supposed to calculate the double integral over the given domain of xy dA, where D is the region enclosed by the following. And we're given two functions, y equals x and y equals square root of x. Okay. Okay, so this is all we're given. And what I would suggest whenever you're given something like this is to try to graph it if possible, if you're not given some like crazy functions. And these are pretty mild, I would say. So if we have something like this, then we can try to graph them. And so the y equals x looks like that. And the y equals square root of x looks something like, okay, this is kind of difficult, but okay. Something like that. And it goes off that way. Okay, and then they intersect at, I'll just label it now. But I'll tell you how to find intersections if it isn't pretty clear. What you would do to find the intersecting point. So intersection when the two functions are equal. So then we do x equals square root of x. And then the only thing that would make those equal is 1 or 0. And they do intersect at 0. So x equals 0 or 1. So that's how we find the bounds for x. Okay, so as we see here, it is what? So if we were trying to draw a line between the two curves in this domain here, so this is our D, right? We could go up and down, right? And we can make vertical lines, and we're good. So this is vertically simple domain. Okay, so that means we're going to have a y bounded by two functions of x and an x bounded by two constants. So we did already find the two constants, right? So this is 0 and 1 because x doesn't go past those. And y, let's find out what it is. What's its lower bound? So what curve bounds it on the bottom is y equals x. So our function of x is just x. And on the top, that curve bounding it above is square root of x. Okay, so this is what that's going to look like when we are setting it up as vertically simple domain. Okay. So now we have all the information we need. Oh, and we know that our f of xy is x times y. So, okay, so now we're ready. So we're going to set up the constants on the outside, right, as the outer. So then we have 0 to 1 and dx. And then on the inside we have x to square root of x, and then a dy. I don't know why I'm putting these that far. And then we have our f of xy, which is xy. Okay, yeah, excuse the spacing. That was pretty bad planning on my part. Yeah. Okay, so this is what it is all together. And now we're just going to solve. Okay, so I'll continue this on the next slide. So this is what we have. I'll write it like a normal person. X to square root of x, xy, and then dy is on the inside and dx is on the outside. And this is good because when we make the x rainbow kind of thing, all of the x's are contained within it, including the bounds, right? And then all of the y's, of course, are contained within it as well. Okay, so getting started, we're differentiating, we are integrating with respect to y first, right? So we're going to treat x as a constant. We'll keep everything on the outside the same. And then, let's see what we have here. So x is a constant, so x just stays there. And then y is the one being integrated. And then our bounds are y equals x to y equals square root of x. Okay? and then we have our dx on the outside. Okay, so now we have this, and what I like to do is just take out the constants, so we don't have to bother with those until the end. So I'll take out 1/2 in the front, and that'll just stay out there. It'll hang out until it's ready to be useful. And then we have x on the inside, this x here, times y squared. So we'll do the top one first. So square root of x squared minus x squared, and then dx. Okay, so this becomes a 1/2, 0 to 1, and we're just going to simplify here. So this turns into an x. So we have our x outside, and then x square root of x squared is x minus an x squared dx. And then on the next step, I'm just going to simplify a little bit. So then we have x squared minus x to the third, and then dx. Okay. Now we're down to single variable calculus again. So this is good. And we just have a 1/3 x to the third minus 1/4 x to the fourth, when x goes from, with x going from 0 to 1. All right. And then we have 1/2 times 1/3, because that turns 1 to the 3. 1 cubed is just 1, minus 1/4, and then minus a 0. So then we get 1/2 times 4/12 minus 3/12, which is 1/2 times 1/12, 1/24. All right, so that's our answer, 1/24. And this was solving it as a vertically simple domain, right? But as you can see, I'll show you on the next slide, what we're going to be doing now is an example of changing the order of integration. So let's say, all right, so I'll write this at the top. So changing the order of integration. So for this, it is very useful to draw the graph. So again, I'm going to be doing the same problem. Okay, so integrating twice over d with x, y, and dA. Okay, where d is the following: the region bounded by y equals x and y equals square root of x. That's y equals square root of x, and this is y equals x. All right, and this is our d. Okay, so now you know how I said in the previous problem that we just did, which is the same one, that this was vertically simple. What if I wanted to draw horizontal lines? Could I do that? And it turns out that I can, right? So sometimes you'll find that some regions are both vertically and horizontally simple, which is good because then you can just get creative with it and choose whichever one speaks to you, basically, or whichever one is easier, actually. Sometimes there's a more preferable one where the solution is relatively simple, and the other one's kind of more difficult. So we'll solve it this way, and I'll show you that it comes out to be the same thing. So now we're looking at this as a horizontally simple domain. Horizontally simple domain. Okay, so in this case, we have to have x being bounded by two functions of y on either side, right? And y having constant bounds, so like numbers, right? So again, we can, what we'll have to do here is get things in terms of x. So you know how in the previous one we got y equals x and y equals square root of x, because that's what we were given, right? And these are both functions of x. This was like our, g2 of x, and this was our g1 of x. All right, so what we have to do here now is find g1 of y and g2 of y. All right, and where g1 is the left one. So this will be the left one, and this is the right one. And then y is just bounded by two numbers. So to get the left one, so that would be, we just need to take this function here, because that's on the left, right? The square root one bounds it on the left. So we're going to take y equals square root of x and get it in terms of, or get x by itself, basically. So if we solve for x by itself, we get x equals y squared, right, because you square both sides. And then this is our g1 of y, okay? And then as for the other one, what curve bounds it on the right is just y equals x, and we're going to get x by itself, and it kind of, oh, hold on, I just gave it away there. So we have y equals x, and we want x by itself, and it already is by itself, so that's good. X equals y, and this is our g2 of y. This is on the right side, okay, left side, right side. All right, so we got our lower bound, or our left bound, and our right bound. So this is going to be y squared from here, right? And then y at the top, or on the right side. Okay, and now we just need to find what the bounds for y are. And you would do this in the same way. You would solve in the same way. You set the two equations equal, so y squared equals y. And the only thing that makes that true is y equals 0 and 1. So we have 0 and 1. So as you'll find in a lot of these problems, it's finding the bounds that's the most difficult part, basically. Well, for the most part. Okay, so these are our bounds, and I'll set it up on the next slide. Okay, so we have our constants going on the outside, so 0 to 1, and that'll be our dy at the end. But anyways, and then we have going from y squared to y, and our f of xy is still xy, and then we have dx, dy here. So the whole concept here was changing the order of integration, right? Because in the first way we did it, the vertically simple, we had dy dx. But now that we changed into doing the horizontally simple method, then we had to change the order here. And that's what I just did. So now we just integrate like normal. So we look at the inner integral, and we are integrating with respect to x, so that means we're holding y as a constant, y constant, so that's just like treating it like a number. So we have our bound over here, and then we have x, treating y as a constant, so y is just there, and then we integrate with respect to x, so it'll look like that, and x goes from y squared to y. Okay, and our dy is on the outside. Alright, so if we continue, we get 0 to 1, and then I'm going to bring the 1/2 out in front just because I like doing that. Like that, okay, and then our y is still sitting there, and we have x squared, so now top minus bottom, so that would be y squared when you plug in y, minus y squared squared, right? Okay, we have a lot of parentheses. Okay, lots of y's. Alright. Okay, so now I'm going to simplify, and this will be y times y squared minus y to the 4th, okay, and then a dy, and then we get that this is 1/2, 0 to 1, of y to the 3rd minus y to the 5th, dy, and now, again, we're back to single variable calculus, so 1/2, and then we have a 1 over 4 y to the 4th minus 1 over 6 y to the 6th. And y goes from 0 to 1. Alright, and now we're just going to plug it in. So we get this, minus 1 over 6 minus 0. And this equals 1/2 times 6 over 24 minus 4 over 24, which is 2 over 24, and that's 1 over, the whole answer turns out to be 1 over 24. Yay, fraction math. Okay, and as you can see, this was the same answer that we got from the other method. So, okay. Alright, now for second to last important topic of the section.
'Cause I be doing the most.
I grew up a fucking screw up. Got introduced to the game, got an ounce and fucking blew up. Chopping rocks overnight.